Good afternoon, everybody. I'd like to discuss the November 2020 Grade 11 exam paper, as the questions that appears here would also be examined in matric. The first question has an object with a weight of 50 newtons that is hanging from two strings as shown in the diagram. If the components of the tension T2 is 20 newtons upwards and 15 newtons to the right, then the components of T1 must be. Now let's look at the situation. T2 has a component of 15 newtons to the right. So T2's X component is 15 newtons and T2's Y component is 20 newtons. Now, T1's components must cancel out T2 component and the weight. So the weight of this thing is 50 newtons downwards. So the two X components should be in equilibrium. They should balance each other out. So T1 has an X component of 15 newtons. The two Y components must cancel the weight. So the net Y component up must cancel out the 50 newtons down. So T1's Y component must be 30 newtons because the 20 newtons of T2 and the 30 newtons of T1 adds up to 50 newtons up. So altogether you have 50 newtons up and you have 50 newtons down. So these forces are balanced. So the only possible answer here would be B, with T1's components 30 newtons up and 15 newtons to the left. 1.2 says inertia can best be described as, and this is a theory question, and the only correct answer here would be the tendency of an object to resist the change in its state of motion. So the tricky part here was question 1.3 says when the potential difference, now the potential difference is V, across a lamp is doubled. V is doubled, so you have to multiply it by 2. The energy dissipated per second, that is power, because power is defined as the energy transfer per second. Dissipated and transferred is the same. So we know that power is V squared over R. I'm looking for the relationship between power and potential difference. So that is a suitable equation to use. You could say, but why don't you use power is VI? Because the current is not constant if you change the potential difference, but the lamp will have a constant resistance or the same resistance, should I rather say. Whether the voltage is V or 2V, this would be the same. The resistance would be the same. So, power is directly proportional to the voltage squared. Now, if the potential difference is doubled, what happens to the double when you square it? It becomes 4 times what it was. So the power energy dissipated per second will be 4 times more. 1.4 says which one of the following components has a dipole-dipole forces. For this, we need to be able to use electronegativity. To discover the polarity of the bonds. And we need to look at the shape of the molecules to find out whether the charge distribution is asymmetrical. Now, the first example there is HCl. If you use the electronegativities on the periodic table, you will discover that chlorine has a greater force of attraction on the shared electrons, and hydrogen will be polarized positively, chlorine will be polarized negatively. So this is a polar molecule. If it's a polar molecule, there will be dipole-dipole forces between the molecules. Carbon dioxide is linear, like hydrogen chloride, but the charge distribution on the molecule would be symmetrical. So this is non-polar. Okay, chlorine would be non-polar as well. And carbon tetrachloride, so the 3 examples A, B, and C would be linear in shape. Linear. So the difference in the polarity and the charge distribution would determine the polarity of the molecules. Carbon tetrachloride is tetrahedral, and it is surrounded, the carbon as a central atom is surrounded by chlorines. The chlorines would be polarized negatively. Once again, you can see that the charge distribution is symmetric, so this molecule is also non-polar. Question 1.5 says, consider the reaction represented by the equation below. 2 moles of iron reacts with 3 moles of carbon dioxide to produce 1 mole of iron oxide and 2 moles of carbon monoxide. And for this reaction, delta H is positive 53.2 kilojoules. So that's the change in the enthalpy, or it is also called the heat of the reaction. It is greater than 0, and that means that the reaction is endothermic. Which one of the following statements is true? For each mole of iron that reacts, so not for 2 moles, for 1 mole of iron that reacts, 53.2 kilojoules of energy is released. Nonsense. It is absorbed. But 53 kilojoules of energy is absorbed for 2 moles of iron. So for 1 mole of iron, half that energy would be absorbed. So D is the answer there. Question 1.6, a substance that donates electrons. So there is an electron transfer taking place. So that cancels option A and option B. Now, an electron transfer, that the donation of the electrons means a loss of electrons, and if it's lost, then the process is called oxidation. So this substance is being oxidized. So this substance is the reducing agent. This brings us to the end of the first video. Thank you for watching.